physical and mental care for fit or disabled senior citizens is an increasingly growing market for new technology solutions, especially technologies that incorporate robotics. Although such robots might seem unorthodox today, they are already becoming an integral element of elder care. This project aims to develop a similar robot that can move, see and speak. The elderly can use this robot as a guide to move around their room where the environment is somewhat fixed. The robot can monitor the elderly if they fall or leave the room when placed in a strategic location in the room. Finally, the robot can also speak to the elderly by giving them greetings, etc. This alleviates the pressure on the caretakers as they can rely more on this robot and save time and other resources when taking care of the elderly patient. In this project, Robotic Operating System, ROS, Kinetic CAM was used on a Turtlebot 3 Burger model to conduct simultaneous localization and mapping, and navigation in a fixed environment that is elderly's room. The master PC was running on Ubuntu 16.04 version. Raspberry Pi camera module V2 was used to monitor the elderly's movements in the room. Lastly, a wired speaker was connected to the Raspberry Pi to play audio messages. The developed robot does show promising results that can be further developed in the future to build a more interactive companion robot for the elderly. SLAM involves the positioning and sensing of the robot to form a map. It is a technique used to move the mobile Turtlebot 3 when placed in an unknown location in an unknown environment and for it to incrementally build a consistent map of this environment while simultaneously determining its location within this map. In this project, the map is created using the G-mapping technique. The G-mapping node is used to combine data from the laser scan and odometry into an occupancy map. The map is built using TeleOperate via the remote PC keyboard. First, the Turtlebot is moved around via teleoperation in an environment that will be used for navigation, and the G-mapping node is used against the recorded laser scan data to generate the map. The map is then saved in a file and opened through Adaptive Monte Carlo localization package to complete the navigation. Navigation allows the robot to move from one location to the specified destination in a given environment using the map, from SLAM, that contains geometry information of the given environment. The map is created with the distance information obtained by the sensor and the pose information of the robot. Navigation allows the robot to move from the current pose to the designated goal pose on the map by using the map, robot's encoder, inertial sensor, and distance sensor. A simple application was created to detect elderly's motion and send a notification to the caretaker's mobile phone with a message, a still image, and a video. The Raspberry Pi camera acts as a data source that continuously scans for motion and records video every time it detects motion. The push-bullet application is the message broker that sends the files and messages between Raspberry Pi and the Android phone. The Android phone receives files and messages.
Good morning, Mr.
Finally,
How
the
are you
eSpeak software is a standard package available in the Stretch version of Raspbian Linux. The Raspberry Pi can now play any audio file that the caretaker wishes for the elderly to hear.